Hello everyone, in this video we write a function to simulate a gambling game with a strategy. The game is coin toss. Our strategy. We decide the initial amount to bet and then we always bet on head. If we win the game, we bet the same amount in the next game. If we lose the game, we double the amount of the previous bet. We leave the game as winners if we win the target amount of money. That is, we need to reach at least the amount of initial capital plus target money. We leave the game as losers if we don't have any capital left to bet accordingly to our strategy. So as always, first I show you what the function does and then we write it. So as you can see, I've already the function here in my environment. So in the following function, 10 represents the initial capital, 1 represents the initial bet, 5 represents the amount of money we want to win. This means that we leave the game as winners if we win at least $15. 10 plus 5. So let's see what the function does. Let's run. Here we have the result. We won. Now let's have a look at the result. Here we can see that here we have a data frame. We have a number of games. Games 0. So we are not playing. So there is no bet, no outcome. But this is our capital available, $10. This 10 here. Then games 1. We bet $1 here, this one. The outcome 1, this is head, so we won. And our capital becomes 11. Game 2. Because we won the previous game, we bet the same amount, so $1 again. And here we won again. So our capital becomes $12. Game 3, we bet again 1 because we won the previous game. But now 0, this means tail, so we lost this game here. And our capital becomes 11. So game 4, we have to double now because we lost the previous game. So now we are betting $2. But we lost again, 0. So our capital becomes 9. So game 5, we have to double. So now we are betting $4. But this time, here we won. So our capital becomes $13. So game 6, because we won the previous game, we bet the same amount. So we are betting $4. This time we won. So our capital becomes 17. Since our target was at least 10 plus 5, 15, here this condition stops the loop, basically, stop the function. So this is the amount and we are the winner. We can see the plot of this game here. As you can see here, this is our simulation. So we start with capital 10. So we went up to $12. Then we lost 11, again 9. And then we won the consecutive, so $13 and $17. And as you can see here, capital after game, $17. We have these two horizontal line. One here is at the level of the initial capital, and this one at the 0 level. So this is what the function does. So let's see how we can write this function here. So this is the name of the function, sim underscore bet underscore coin underscore toss. So it takes 3 arguments, k, bet, and target. K is our capital for betting. Bet is the initial amount of bet. Target, the sum we want to win. Total to leave the game is k plus target. So we need 2 packages, ggplot, ggplot2, and scales. So make sure that you install these packages. Okay, here we generate these 2 objects, total k equal k and bet equal bet. We initialize the data frame. So df data frame and takes 4 columns, and games, bet, outcome games, capital available. So end games equals 0, so this means that we are not playing yet. So means that bet, we are not betting. This is not an outcome of the game, so this takes value NA. Capital available is here equal to total K. We initialize also counting games, so N equal 1. And here we check if we have enough capital to bet. So possible underscore bet is total K minus bet. Now we have the loop. This is a while loop. The conditional statement to activate the loop. So possible bet greater than 0 and total K less than K plus target. So if these two statements are satisfied, here we run this loop runs. Outcome of game. Outcome game here, what do we do? Basically, we use the sample function. So we take one element from this vector with 1, 0, and naturally we replace. If outcome game is equal to 1, we win. So we generated this object win-loss, and that takes the value of bet. Else, so if we lost the game, so outcome game is equal to 0, win-loss is equal to -1 times bet. We have to update capital. Total K, here df capital available n plus win-loss. Win-loss is all this one if we won, or this one if we lost. And notice here capital available n. Let me show here. Capital available, this is basically df. Capital available is this column here. N, if you remember, is this one. It takes value 1. Now remember that R start indexing from 1. So this means that here n games 0 is at index number 1. So this n means basically that total K is equal to the previous capital plus this plus or minus this win-loss. So when n becomes 2, so we are here, basically, this 2 corresponds to game 1. So basically, we are referring to this capital available here. Okay. So after that, we have to update the df. So first of all, we generate a new data frame df2 with the result of the current game. So n, bet, outcome game, total K. We set the column names of df2 as the column names of df. When we have done this, we generate this new df. Basically, we row bind df with df2. So basically, we overwrite df. We update number games as n plus 1. We have update bet. If outcome game is equal to 1, the bet is equal to the previous bet. Else, if outcome game is equal to 0, so we lost, bet we have to double. So this is 2 times bet. We have to check if we have enough capital to bet. So possible bet, again, total K minus bet. And now this total K is this one. So we want to make sure that we have capital to bet. Basically, check this condition here. And this is where the loop ends. So the loop ends when basically the conditional statements are false. Outside the loop, we made this plot here. The code here is already familiar to you. What is new is just this one, subtitle. Subtitle here, I use the paste function, paste 0 to paste this capital after game, column, dollar, comma, total K. And again, total K is this one, so the last one available. Here 17 corresponds to this one. Okay, so we generate a list with results equal to df, the data frame with the results of the simulation, a graph equal p, this p here. Then we print the message, so if total K is less than 0 or possible bet is less than 0, print you lose, else print you win. Finally, we return the list here, this L object. So this is what we have done. So let's run again together. And let's test it again. Here, our initial capital is $100. We bet, initial bet is $1 and we want to win $50. So we leave the game if we have at least $150. Let's try. And as you can see, we lost. Let's see here. Yeah, you lose. And these are the results. So let's see what happened. Again, this is game 0. Capital level is 100. First game, we bet $1 and we lost, so 99. Here, second game, we doubled. We won, so our capital 101. We bet the same because we won the previous game. Again, here we won again, 103. Again, we bet 2, but this time we lost that, so capital 101. We have to double, but we lost, so 97. And here we have to double again, but this one we won. So again, here we play we bet $8, but this time we lost. Our capital here 97, and we have to double, and this one we won. So our capital 113, and I think that we are here. And then we play the same because the previous we won it, but this time we lost. So 97. We go here. And then we have to double, 32, but this one we lost again. So 65. And we have to double again here. 64, but we lost. So we are left with $1. And here we cannot bet anymore accordingly to our strategy. So the game has ended. This possible, if you remember here, possible bet, this has turned false. Where's that? Yeah, this has been turned false. Okay. So let's try another one. Here we are always we start with $100 capital. We bet $5 this time. This is our initial bet. We want to win $75. Let's see. And we lost also this one. Okay, let's try another one. Yeah, our capital is 500. We bet $10. And this one we won it. As you can see here, 1990, 1990. Let's check the last one. Here. This one we lost, capital 370 and 370 here. And again, we can store the result here. This one, you win. Let's see the results. As you can see, this is the simulation 165. Let's see the plot. And this is the plot, 165. Okay, guys, that's it. I hope this video is interesting. And if you enjoyed this video, see you in the next one.